Hello, this is Professor Kyle Mack, and you are watching 13-3 Lesson Intro in 5 minutes or less. So what we're going to look at today in this section are size transformations. We're going to talk about how you need to have a center and a scale factor, talking about the impact of various values on the scale factor and how that will make the image look very different. And then also we're going to talk about succession of isometries and then a size transformation. Alright, so size transformation is known as a grow or a shrink, a dilation, a stretch, or a compress. Oftentimes you'll hear me use the term dilation quite a bit. So the center of a size transformation can be either in the interior, on the figure, or exterior. So this would, right here is a diagram of what it would look like if you had a center of dilation in the interior. This would be a center of dilation that is on the figure. And this one is exterior. So you can see what happens here. Scale factors need to be stated as a single value. They can be stated with a fractional value, so it could be like 2.5, or it could be 1/2, it could be just 2. It also can have a negative value, like -5. What you see here is a scale factor of 2. Notice how the distance from the center to the figure is half the distance of the dilation center to the image for each of the corresponding parts. What will happen is, with a scale factor of 2, all of your side lengths will be double. Alright, so in this slide what we're going to do is we're going to look at scale factors and how different values can manipulate the scale factor and then ultimately manipulate what the final image will look like in a size transformation. So in essence, a scale factor is a value that you multiply the initial value by to get the new value. Because of that, just like in relationships with multiplication, like a negative times a negative equals a positive, there are certain associations that we can make based upon the values of a scale factor. The first thing is if we have a fractional value or a decimal value that is greater than 0 but less than 1. What will happen is we'll have a shrink. This first diagram shows a shrink. We go from B to B prime, which is half the distance away from the center. The center in this particular size transformation is the origin. We'll also notice that B to A is twice as large as B prime to A prime, so that means that we had a shrinking occur from the original image to the new image. When values are negative, they have opposite directionality. If the origin in the second diagram was your center, you would expect to see everything stay within the first quadrant. But it doesn't. It goes down to the third quadrant because we have opposite directionality. Notice that the orientation of the figure is also a little off because now WZ is on the top. But in addition to this concept, we also have to understand that if the absolute value is greater than 1, it will still have a growing effect. So the size transformation, the scale factor of this size transformation is -2. So we still have a growing by 2, or multiplication by 2. So for example, WZ is 2 units, W prime Z prime is 4 units. Finally, you cannot have scale factors of 0. And that has to do with the fact that whenever you multiply any value by 0, you get 0. And so if I were to take a scale factor and have it as 0, any value that I multiply that by will be nothing. It will be 0, an empty set. Alright, the last thing we're going to look at is successions, specifically a succession of isometries and then a size transformation. So remember, there are 3 types of isometries: translations, rotations, and reflections. Typically we're going to have 2 or more isometries, and then the final transformation will be a dilation or a size transformation. So if we look at the figure provided, we have A, B, C as a triangle. It first translates, then it reflects, and then it grows. And so what you'll do is you'll actually step by step discuss each of the different transformations and give each of the different units that are needed, like I have right here below. And that's how we show successions of isometries, and then a size transformation. That concludes this tutorial.